what I want to talk to you about here is the difference between what we would call a concentrated acid and a dilute acid. Okay, so I want you to imagine, and I've got one beaker here, okay, and one beaker here. Now let's say, let's call that the water line there, and I'm just going to add some water into these beakers. Okay, let's say that I've added 50 centimeters cubed of water and 50 centimeters cubed of water. Okay, now into beaker A, I decide to add some acid. Okay, so these red dots here are the acid particles. Okay, so I've added 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's just say I've added 11 centimeters cubed of acid. Whereas in here, I've added in fact, I'm going to change this to little acid, okay, and lots of acid. So in this way, we can say that although both beakers have the same volume, beaker A has a lower concentration, okay, or more dilute than beaker B. Okay, so hopefully we can see that this is low concentration, okay, and therefore it is dilute, and this is high concentration, which is concentrated. Okay, so let's just add a little bit on here. So this is because beaker A has fewer acid particles in the same volume as beaker B. Okay, so essentially what this means is I want you to imagine that these particles are moving about all the time. Okay, and because these are liquid particles now, so if they're all moving, okay, if there's lots more of them, the ones in beaker B are going to be colliding a lot more frequently than the ones in beaker A. So all that means in terms of a rate of reaction is that, so that's right here, any chemical reactions will happen faster in solution B than solution A due to the higher concentration. Of acid. Now you don't need to know any more than that at this stage here. This is not the same as strong versus weak. Okay, so strong versus weak is not the same. all I want you to know at this stage is that your strong acids, okay, I'm just going to scroll down, okay, so strong acids equal hydrochloric, sulfuric and nitric acid, whereas weak acids are citric acid and phenolic acid. So different types of acid might be strong and weak, okay? But let's take, just for example, some hydrochloric acid. So e.g. hydrochloric acid we could have in beaker A and beaker B. And I would like you to ask yourself, which is the more concentrated solution? Okay, so this is the concentrated hydrochloric acid, whereas this is the dilute hydrochloric acid. So it's the same acid, it's still a strong acid, and we're not going to go into too much detail about why that is. If you'd like to know, just send me a message on chat and we can have a go through that as well. But essentially, we're just looking here at the differences between dilute and concentrated. And it's just like when you make yourself a glass of squash at home. So let's say I fancy a glass of orange squash, okay? If I add a little bit of squash, okay, or if I add a lot of squash and not much water, okay, it's just like saying this here is dilute squash, whereas this is concentrated squash. That's just as an example. Okay, so I hope you found that useful. Do send me some questions if you're unsure and I will get back to you. Well done, bye.